So a rational function is really a fraction type function where q of x can't be the number 0 in the denominator. Remember, you can't divide by 0. So any value that would make the denominator equal to 0 has to be avoided. So we're going to be finding the domain of rational functions. Remember, domain are the values of x that you can use in the function. So it goes through and states what it is again. Denominator cannot be equal to 0 or it'd be undefined. So to find those undefined areas, we're going to create an equation with the denominator, set it not equal to 0, solve for x, and then write our answer in interval notation stating what the domain can be. So for this first one, find the domain. So we want to avoid numbers that will make the denominator 0. So to do that, you could probably look at it and go, well, x can't be, but let's write it all out. X can't be, subtract 4, the number -4. So for the domain, we can plug in any other number, just not the number -4, because we're going to run into trouble. We're going to be dividing by 0 here. So think about that on a number line for a moment. X can't be the number -4. So you got a big old open circle there. It can be any number to the left of it, any number to the right of it, but it just can't be -4. So in interval notation, we start from the left, -4, all the way over to the number -4, or negative infinity rather, all the way over to the number -4, parenthesis, and then pick up the other side of that, -4 out to positive infinity. Remember, there's always parentheses on infinity symbols or next to infinity symbols, and then there's a parenthesis on the -4 here. We don't put a bracket because a bracket, remember, means a filled in dot. We have an open dot here. We can't use the number -4, so we use parentheses to indicate that. For the next one, state the domain. And again, domain, we worry about the denominator only, not the numerator here. So we set the denominator not equal to 0. And because this is a quadratic, we're going to have to factor it. So I'm going to write down 2 sets of parentheses, x times x to get x squared, has to multiply to get -14, but then add to get the number -5. So do the multiplication first. I know 7 times 2 is 14, and 7 and 2, but it's got to be opposite signs. So I'm going to do a -7, positive 2 is -14, -7 plus 2 is -5. So my numbers in here are -7, positive 2. Set each factor not equal to 0, solve for x. So we have to avoid the number 7. Subtract 2 from both sides. We have to avoid the number -2. So again, think about that on a number line, what that would look like. We can't use the number -2 or 7. But all other numbers on the number line are good to go. So notice I have 3 areas that are shaded in. So my interval is going to be from -infinity to -2. Then I'm going to pick up this interval here between -2 and 7. And then from 7 out to infinity. That's your interval notation. All right, for this one, again, find the domain, focus on the denominator. Set that not equal to 0. Now, this one doesn't factor. I can't do x minus 2, x plus 2, because that's going to give me a -4. And if I try x plus 2, x plus 2, that's going to give me a middle term. So I could do this. I could subtract 4 from both sides and then do the square root. But we see that the square root of -4 is imaginary, right? That's 2i. And we're looking at a real number line here. So 2i doesn't occur on that number line. So there is no place that we have to skip over. So our domain for this is negative infinity to positive infinity. I could have used any number to plug in there and it wouldn't have made the denominator 0. I want to think about it. If you plug in negative 2 down here, negative 2 squared is 4. 4 plus 4 is 8. So that's not going to make it 0. There's no way that you can make that denominator 0.